We have to find the power series representation for the given function, and we're going to start with power series of 1 over 1 minus x, which equals to sum as n equals from 0 to infinity of x to the power of n. So we're going to modify this expression to get our function on the left side. So the first step is to replace x with negative 4x. We're going to have 1 over 1 minus negative 4x equals sum from 0 to infinity instead of x, negative 4x to the power of n. Therefore, we get 1 over 1 plus 4x equals sum from 0 to infinity of negative 4 to the power of n times x to the power of n. Second step is going to be to differentiate both sides of equation. So we're going to differentiate with respect to x, both sides. On the left side, we're going to use chain rule, and we get negative 4 over 1 plus 4x squared. And on the right side, we're going to differentiate only x to the power 2n. So here we're going to use chain rule, and now we have sum from 1 to infinity of negative 4 to the n, and derivative of x to the power of n is n times x to the power of n minus 1. So now sum in the right hand side is starting from n equals 1 because first term died during differentiation. So the next step is to divide both sides by negative 4 to get 1 over 1 plus 4x squared equals sum from 1 to infinity of negative 4 n to the n minus 1 times n times x to the power of n minus 1. And we can rewrite this to have sum from 1 to infinity of negative 1 to the power of n minus 1 times 4 to the power of n minus 1 times n times x to the power of n minus 1. And the last step to get our function on the left side is to multiply by x. So we get x over 1 plus 4x squared on the left side, which is our function, and sum from 1 to infinity negative 1 to the power of n minus 1 times 4 to the power of n minus 1 times n and times x to the power of n on the right side. And that's going to be series for the given function.